Good morning. Today we'll be talking about transformations of parent functions. We will be in the form of f of x. So these transformations principles are going to be used for any parent function. So for this video, we're going to use a, b, h, and k. I have seen textbooks or online videos that use a, b, c, d. So it doesn't matter. So if you're using A, B, C, D, then C and H are the same and D and K are the same. Everything in this video is going to be with the A, B, H, and K. So here are the first two rules about transformations. So A is going to always be in front of the function. A is never in parentheses. So A is going to tell us if it's a vertical stretch or compression. Now we look at the absolute value of it. So we don't care if it's a negative sign to tell if it's a vertical stretch or compression. If the absolute value of A is greater than 1, it is called a vertical stretch. A vertical stretch means the graph is going to get taller quicker. It's basically being pulled away from the x-axis. If the absolute value is between 0 and 1, then it's a vertical compression. The graph is going to get closer to the x-axis. It also looks wider. Now, if it's a negative, it reflects over the x-axis. So a -5 would be a reflection over the x-axis and a vertical stretch because the 5 is greater than 1. Okay? So fractions less than between 0 and 1 are vertical compressions. Anything greater than 1 is vertical stretch, and then if it's negative, it reflects over the x-axis. The b value. The b value has to be inside the parentheses, and it has to be in front of your x. Now, we're going to talk a lot about why there's double parentheses here, because if you have a b and h in the same problem, then to find your b, you actually have double parentheses. Again, that's only if you have b and h in the same problem. Now this b value, if the b value is greater than 1, it's a horizontal compression by the reciprocal, which means whatever number you see here for b, you're actually going to flip it. You're going to take the reciprocal. So it technically follows the same rule if you flip it first. If you flip it first and it ends up being less than 1, it's a compression. If the b value was between 0 and 1, then it's a horizontal stretch. And if it's a negative, it reflects over the y-axis. So every time you see b, what we're going to do is we're going to take the reciprocal of whatever we see here. So if b was 5, we say that it's a horizontal compression by 1/5. So here are some examples of A and B. We're going to define our variables and explain the transformation. If it's in front of the f of x, this has to be an A value. So if A is 5, that means it is a vertical stretch of 5. Okay, this means the graph is going to get taller quicker. The second one, if the number is inside the parentheses or inside the absolute value, whatever it is, if it's inside, this is a b value. So my b is a -3. Well, if it's a -3, that means it's a horizontal compression, and we have to take the reciprocal of the 3. So it's a horizontal compression of 1/3. Okay? Remember that the negative does not affect a stretch or compression. But what the negative does is it causes it to reflect over the y-axis. Okay? So B causes it to reflect over the y-axis. Okay, example number 3. It's in front of my function. It's in front of my f of x. If it's in front of it, it's my A value. The absolute value is 2. If the absolute value is 2, is that a stretch or compression? It is a vertical stretch. Now, I don't expect you guys to memorize every single thing that these letters do right now. But if you write these all down, then you can use that sheet with you to tell you what that does. What else does A being negative do? Well, if A is negative, this causes a reflection over what axis? This causes reflection over the x-axis. Okay? And the last one, if it's inside the parentheses, that means it is a B value. So our B is 1/5. Well, with B, remember that we always take the reciprocal. So that 1/5, we've got to flip upside down. We get 5/1. This is a horizontal stretch by 5. Okay? So B causes horizontal stretches or compressions. But the B value, you always have to take the reciprocal of it. Okay? So those are some examples of A and B and what they do. So here are 4 practice problems that you can do. Go ahead and pause this video and try number 1 and 2 on your own. Hopefully you got these correct. So remember, if it's in front of the function, it's our A value. So it's a 1/2, which causes a vertical compression of 1/2. Okay? On the second problem, if it's inside the function with the x, in front of the x, that means it's a B value. And for the B value, we always take the reciprocal. So it becomes a 1/3. So it's a horizontal compression of 1/3. Go ahead and pause the video and try number 3 and 4 on your own. So for this first one here, a -5, remember the absolute value is 5, which is a vertical stretch of 5. And because it's a negative, though, it caused a reflection over the x-axis. When B is -2, remember that we take the reciprocal of the absolute value, so it's really a 1/2 horizontal compression. But because B was negative, it caused a reflection over the y-axis. Okay. Now H and K. H always has to be inside the parentheses with x. So here we see that the H is with the x. Now, why did I highlight this negative? Well, because we're actually going to change the sign. If we see a -2 here, that's really, that means H is a +2. If we see a +2, that really meant it was minus a -2, and H is really a -2. All I'm saying here is whatever you see here, H is really the opposite. So if you see an x -5, that means that H is really a +5. So H always lies to us. It's always the opposite of what we see. And after we change the sign, so again, after we change the sign, it tells us if we go right or left. After we change the sign, if it's positive, it goes right. If it's negative, it goes left. K will never be inside the parentheses. K has to come after everything. I've seen K written in front. That's just, just rewriting it. But K cannot be in the parentheses with the x value. And whatever you see here, if you see a +5, it goes up 5. You see a -3, it goes down 3. So K is going to control your up and down movement. It also controls your range. Okay. So here are some practice we're going to do with H and K. If it's inside the parentheses, that means it's an H value. If it's an H value, we always have to change the sign of what we see. So H is really a +2. So that means this graph is being translated to the right 2. You have one inside, one outside. Now, when we have both, it's actually easier. What it's trickier is when you only have one to differentiate. Do you have an H or K? So here we have both. Inside the parentheses is an H value, and we always change the sign. So it's not a positive one, it's a negative one. So this graph is being translated to the left one. The k outside the parentheses, the k is 4. Remember that k always controls your up and down movement. So this graph went up 4. For example 3, again we have an h and k. H is inside the parentheses always, and we change the sign on what we see. So this is going to the right 4. Outside the parentheses is my k value. If k is a negative 3, it's going down 3. Number 5, there's only one number and it comes after the parentheses. So the k value comes after the parentheses, and it tells us that the graph is going down 5. So here are some practice questions for you to do. Go ahead and pause the video and try these on your own. Okay. Hopefully you got these all right. If you want to look at them, write them down, check your work, you can pause this video. Okay, let's continue from there. So here we're going to include all of them, okay? Most problems are going to have multiple transformations to it. So remember that let's classify if they're A, B, H, or K. If it's in front of your function, and this will never be inside your parentheses, this is an A value. So my A value is a positive 5. Well, what does A5 do? It causes a vertical stretch of 5. Okay. Now, inside my parentheses, which of the variables goes inside of my parentheses? That would be my H value. And my H is always the opposite of what we see here since the equation had a negative in it. So I'm really subtracting a positive 2, which means this graph is going to the right 2. Here we have a negative 3 that is inside with the x in front of the x. That means it is a B value. So my B is negative 3. Well, don't forget that B does horizontal. Is it a stretch or compression? Well, if the absolute value is greater than 1, it is a horizontal compression, and we have to take the reciprocal of the 3. So it's a horizontal compression of 1/3. The 4 comes after the parentheses, so that is a K value. When K is 4, it goes up 4. Now I did forget one thing for the B. When B is negative, what else is happening? It causes a reflection over the y-axis. Okay, that's example 1 and 2. Let's look at example 3. What variables do I have here? I have a number that's in front of my function, okay? So I have a negative 2 here, and I have a plus 1 inside my parentheses. This is going to cause a vertical stretch. Remember that we look at the absolute value of this number. So it's a vertical stretch of 2. What does the negative do? It causes a reflection over the x-axis. This number is inside the parentheses. If it's inside the parentheses being added or subtracted to the x, that's my H value. But H, we always change the sign. So this is really going to be H is negative 1, which means this graph is going to the left 1. Let's look at example 4 together. If it's inside, in front of the x, this is a B value. But remember that we always take the reciprocal of it. So this is going to be a horizontal compression by 1/5. And this value comes after the parentheses, so this means it is the K value, so this graph is going up 6. Now let's go ahead and you try some practice questions on your own. Go ahead and pause this video and try number 1 and 2 on your own. Okay, so hopefully you got everything correct there. Now, let's try number 3 and 4 on your own. There's number 3 and 4 for you. Vertical stretch of 2, right 1. A and H. B is always going to be inside parentheses, so B is -8. We take the reciprocal and we're telling us how much was the horizontal stretch or compression. And the K has to come after the parentheses, and K goes up and down. This one up 1. So one thing that we don't see a lot of is having B and H in the same problem. So remember how I mentioned the double parentheses? So whatever I have here, I actually have to factor this out, okay? So I look at this first problem and I look at this value and I have to take a 5 out of this equation. Now that 5 is going to stay inside the double parentheses. So I'm basically like undistributing the 5. So I have a plus 10, but because I'm factoring out a 5, what is 10 divided by 5? It's a plus 2. And here is where the double parentheses come into play. Okay, so in this problem, my B is 5. So this has a horizontal compression of 1/5. And this graph is not going, if we just looked at this, we would say, oh, this graph is going left 10. The graph isn't going left 10. Because this 5 is in there, this graph is actually only going to the left 2. So my H is only a -2, and it's going to the left 2. So whatever this number is, I have to factor it out. So I'm going to factor it out, and it's going to go in here like this. And so you're going to have the double parentheses. So this is going to be 3 parentheses x. Now I have -6, but I factored out a 3. What is -6 divided by 3? The answer is -2. So now this graph has a B value of 3, which is a horizontal compression of 1/3. And H is a positive 2. So this graph is going to the right 2. Okay. So again, we look at the number if there is a B and H in the same problem. So we only do this if there's a B and H in the same problem, is we have to factor this out. So in this problem, I'm going to factor out a -4. So I'm going to factor out the -4, which means I'm going to divide everything by -4. What is -8 divided by -4? It equals to a positive 2. So I'm going to put a positive 2 here. So again, I'm factoring out the number that's in front of my x. This means that my B value is a -4, which is a horizontal compression of 1/4. What does the negative do? So guys, remember, stretch and compression, it's always a positive number. Okay? One might be facing up, one might be facing down the graph, but it's still, the compression or stretch value is always positive. Now, what does the negative do? The negative causes a reflection over the y-axis. So my H, after I factored out that number in front of the x, my H is really only a -2. So this graph went to the left 2. Okay. On example 4, I have to factor out the number that's in front of, so I'm going to factor out a 2. So f of 2x. Now what is 5/2? Well, we can put 2.5, or we can just leave it as a fraction, 5/2. So fractions are okay to have here. So my B value is a positive 2, which is a horizontal compression of 1/2. And my H value is -5/2, which means this graph went left 5 over 2, or 2.5. Okay? Go ahead and try number 1 and 2 on your own. Okay, so here are the answers. Again, I had to factor out a 2 here, and I was left with x plus 2. So my b value is 2, and my h value is negative 2. Okay, so this graph went to the left 2 and had a horizontal compression. On this one, I had to factor out that 7. So I was left with a 7, and then parentheses x plus 2. So horizontal compression of 1/7, and to the left 2. Go ahead and try number 3 and 4 on your own. Pause this video, and when you come back, the answer will be there. Okay, let's see how your understanding was. On this one, I had to factor out a negative 3. So 6 divided by negative 3 gave me a negative 2 in here. So h is really a positive 2, which went to the right 2. B is a negative 3, which means a horizontal compression of 1/3, and because it's negative, it reflected over the y-axis. On number 4, I had to factor out a 4. Well, 7 doesn't divide by 4 evenly, so I left it as 7 over 4, which means it went left 7 over 4, okay? And it had a horizontal compression of 1/4. So here's just a few more extra examples that we're going to practice together, okay? So for example number 1, what is my a value? Negative 5. What does a negative 5 do? It causes a vertical stretch of 5. Remember that for stretch and compression, we are only looking at the positive value. So what's the purpose of the negative? The negative causes a reflection over the x-axis. What variable is this? Well, it's inside the parentheses, so this is an h value. And we always change the sign on the h, so this is making the graph go to the right 2. For example number 2, this is inside the parentheses, so this is my b value. My b value is 1/2. So if the b value, if the absolute value is between 0 and 1, that is a horizontal stretch. What's the reciprocal? 2. This is outside the parentheses, so this is my k value. This will make your graph translate up 4. Okay. Example number 3. Remember that if you have a b and an h in the same problem, you have to factor out the number that's in front of x. So again, you only have to do this when you have a b and h in the same problem. So we're going to go ahead and factor out the 3. What's left when I factor out a 3? So 9 divided by 3 is 3. So now we have b of 3, which if a b is 3, that is a horizontal compression by 1/3. This is h. H is negative 3, which means this graph is going to the left 3. And the negative 4 is outside the parentheses, which means this is your k value, and this is going to make the graph go down 4. On our last example here, we have a number that's inside the parentheses in front of x. This is a b value. Okay, this is a horizontal compression of 1/2. And then what does the negative do? The negative causes it to reflect over the y-axis. This is a k value because it's after the parentheses, so this causes the graph to go up 6. Now we have a few more questions for you to be able to practice on your own. So go ahead and pause this video, and when you come back, all of the answers are going to be there. Okay, go ahead and check your answers. Hopefully this video helped with general parent functions so that f of x can represent any parent function. And so hopefully this cleared up and explained what a, b, h, and k do. If you like this video and you learned from it, please give it a thumbs up, leave me a comment, and if you want more videos, go ahead and subscribe to my channel. Thanks and have a great day.